Hello, check, test. Hello, hello. Hello, check, test, test. Hello, hello, hello. Hello, check.
I, Varsha, take extreme pleasure in welcoming you all to yet another Elite Guest Lecture Series of Synergy 23, the annual National Technical Symposium of NIT Trichy, organized annually by the Mechanical Engineering Department. We express our sincere gratitude to the chief guest for his valuable time and consideration towards us in this special occasion of Synergy 23. I now request the head of the Mechanical Engineering Department, Dr. K. Selvam sir, to offer the renowned book Chip War by Chris Millers as a token of gratitude to our chief guest, Mr. Suyash Singh sir. Sir, please. Thank you, sir. Today, we are here with one of the pioneers of future technology, Mr. Suyash Singh, whose work and research is inclined towards eminent domains of space technology and electric vehicles. Mr. Suyash Singh is the co-founder and chief executive officer at GalaxEye Space, an IIT Madras incubated space startup. With continuous benchmarking and competitor analysis, GalaxEye Space is managing a team of 40 members. With his support using groundbreaking technologies, GalaxEye Space aims to provide businesses opportunities and motivation for people to work on innovative space technology concepts. Representing IIT Madras, Mr. Suyash Singh founded and headed Avishkar Hyperloop for the SpaceX Hyperloop pod competition in 2018 and developed a method for system simulation. Let's engross our euphoria towards this technical oration and traverse the world of imminent technology. With the exclusive guest lecture, we now call upon our chief guest, Mr. Suyash Singh, to address the gathering. Please, sir.
All right. First of all, good evening, everyone. It's not good morning, so no worries. You can still sleep. That's okay. And thank you so much, sir, for giving this as a platform to me and coming and talking to all of you guys. First of all, chief guest is a really big deal, honestly. Never been as a chief guest anywhere, so still okay, right? I've been one of you guys 3 years earlier, probably sitting in the same space, and I like sitting in that space a lot and learning from all of you, learning from all of the other folks as well. So, yeah, I think thanks for the introduction. Thanks for calling me here, and it's a wonderful campus and a wonderful opportunity to interact with all of you and all together. I'll start with a very brief background of myself. Um, I'm one of the guys, in a nutshell, who likes working on ambitious technologies. Initially, I started my career when I was a student like you. I did my BTech in mechanical engineering way back in 2009. For 4 years, I studied mechanical engineering, and the first thing I ever wanted to do in life was to become a Formula One car engineer. Right? That's it. Nothing else. Right? So I wanted to become that time, an aerodynamics engineer for Red Bull Racing and to design aerodynamics for Sebastian Vettel. That's it. That was my life goal. But unfortunately, or fortunately, I went and started my corporate journey with one of the companies, very mainstream companies called TCS. But I was not in the mainstream division of TCS. I was working on TCS research and innovation. So, thankfully, somehow I reached because of my enthusiasm and motivation in life. And I convinced the CXOs at TCS to put me into R&I, which is research and innovation wing of Tata Consultancy Services. Again, I went there and asked, "Hey, is there a possibility that I can work with one of the automotive manufacturers to build an aerodynamic system for them. So then I was put into Chrysler and Ford automobiles project, and I started doing engine calibration. So all 4 years in mechanical engineering, I studied about thermal, I studied about structural integrity of aspects of a system. I studied about IC engines and stuff. So I thought, okay, if not aerodynamics, I'll at least do IC engine, and I started doing uh, engine calibration. So my job was to tune the fuel air ratio of an IC engine to maximize the efficiencies. That was my job. This was way back in 2014, and there was hardly any machine learning or deep learning algorithm that was used in those days. Right? 2014 or 2015 was the benchmark year for machine learning to grow, but that time was the first ever time when I implemented a regression algorithm on engine calibration of IC engine. Right? And that was the day when I decided not to become an aerodynamics engineer for Red Bull Racing anymore. Then I thought, okay, probably I will do AI on IC engines, because regression was the first foot towards the AI side of the story. Then 3 years I kept doing all documentation, building some applications, building fuel air ratio models for Chrysler, Ford, and a lot of other people. In 2017 or so, after 4 years of my work experience, I understood that probably my knowledge is very less in whatever area I'm working on. And so I was still exploring in life. And in those 4 years, while working on engine calibrations and stuff, I actually learned a lot of technologies. For example, big data, machine learning, Hadoop. I have built I took a computer, put that into my room, and I made my own Google search engine, indexing 500,000 websites per day. It crashed, of course. There was no enough server space. So I did all of those things, and I found out that, oh, hey, probably there is something missing, still something missing, and I have to go back to an institute to learn more. And then I decided, okay, I'll go to IIT Madras. I mean, not IIT Madras in per se, but I started preparing for exams, and I, cracked the exam, and I applied for a few institutes, got IIT Madras Aerospace. When I started my journey at IIT Madras, there is one elective subject that is offered, elective course that is offered every semester. So my aim was first semester machine learning elective, second semester deep learning, third semester reinforcement learning, fourth semester some project, and then take a Google's job and be happy about it. Right? That was my aim. But then I was very opportunistic. When I went into the institute, 2 months later, I was bitten by a bug called Hyperloop. So Elon Musk launched a competition in 2017, which was called Hyperloop Pod Contest, and it used to happen with SpaceX. So all my mechanical curiosities actually came back after taking a detour of AI, Hadoop, machine learning, Google search engine, and whatnot. And then I thought, okay, no, let's build a Hyperloop system again. So in 2017, before actually starting the project, I took a trip from Chennai to Kanyakumari by car, and I actually visited this campus also. So I took a break at CCD and just went to Kanyakumari and came back. And then I started at Project Hyperloop. It took 1 year just to understand what is Hyperloop. It just took 1 year to build a good team. It took 1 year to understand that there is no literature in that domain. And it took 1 year for us to understand that customizations can still be faster than we think. In that 1 year, We built a team of 40 good people, built an architecture, borrowing technology from aerospace, automobile, computer science, electrical, here and there, to make one system, or to at least put one system of Hyperloop on paper. And that year we failed because we were doing a lot of iterations. And we failed drastically. And, you know, being a master student, sometimes is very difficult because you have so much little time to do a project and whatnot. So my directors or like faculty kind of advise not to do it, not to reattempt Hyperloop, rather do a research and, why don't you think more and just do a research, focus on a research paper and just complete that. But I kind of convinced my professor, who's also called, whose name is Dr. Satya Chakravarti, to, give me one more attempt to do that. So he agreed. And in that attempt, we made that paper design to come into reality. People were managing courses and working in the evening times and the other things that brought us together to build a Hyperloop or a winning Hyperloop system that went to SpaceX. We did a pod run and then came back. We were the only Asian team that year to go to SpaceX. And we were the only team who took their flag of the nation in amongst 20 teams and put that on that SpaceX thing. Yes, I'm very proud always to tell that story that, when we were there was a movie that came, if you remember, Uri, the surgical strike, and there was a war cry that they had. We shouted that war cry in Los Angeles with our flag. So it was an amazing journey for sure. So why am I telling you all these, pieces of my story, or how did I started? Where did I land up? 2013. And before that, I was building some Formula student competition, doing some Baja, building some buggy. And from that mechanical engineer to becoming an engine calibration engineer, to becoming a big data engineer, to coming back as an aerospace engineer, and then building a team which took a lot of systems from different domains and put it together. So I'm telling you that because it was possible for me just because there was a curiosity to execute. We always say that we need to be curious to learn, but I say there has to be a curiosity to do execute. And I took all engineering disciplines together to build Hyperloop. I did electronics. We built linear induction motors that is a completely electrical. And that was a novel induction motor that you will ever see. It's not a motor kind of thing. It's like cut, spread out. It's a linear induction motor, not a rotary one. We built levitation mechanisms. We built hardware that can work in vacuum. We designed carbon fiber chassis for the first time. How was it possible without a lot of advisory? Of course, there was a lot of support from the institute and faculty advisors. But how it was possible? It was because I and my team was super curious to execute a project. And that is what I want to tell you guys. You need to be super, super curious and super hungry to not just learn or not just keep it to yourself, but to go and execute. That is where we are here. India as a country And we as a country are at a point or cusp of our journey where deep tech startups have grown like anything. After my Hyperloop successful stint, I moved on, worked in silence for a couple of years, and then started a company called GalaxEye. And I'm not the only one in those years. I'm not the only one. A lot of others. There's a company called Agnikul. There's a company called ePlane. There are more companies, Aether Energy, and whatnot. All of us are doing deep tech. We are not a software country anymore. We are doing a lot of deep tech projects. We are converting them to reach and realize the path of commercialization. We should no more be called as a frugal country who's just making copy pasting the ideas of the West and making it cheaper. We are no more that. We are adding value, we are doing innovative stuffs, and we should be taking a tech first approach from here and now. And I hope some of you will start the similar journeys, will reach significant milestones, and will make, an addition of that delta to entire country's deep tech story. So I'm building, I'll probably talk a little more about what I'm building now, which is nothing but a satellite that will go in space to do Earth observation. What is so special about the satellite, right? We all watch, how many of you watch launch when it is like ISRO is launching a satellite, launch vehicles are going up on TV channels or so? Why do you watch launch? Uh, just raise your hand if you really like this. You watch the launch because you want the rockets to blast off. Some of you. You watch the rocket launches because it is something fascinating, that's something it getting transported to space. Okay, but most of you don't know why do you watch a launch, right? Because it's just visible, it's just presentable. But what happens after the launch? How many of you are curious about that? Interesting. And that is where we need to be more curious. We need to be more curious what happens after the launch. So after the launch, there are some satellites that goes into the orbit that is used for navigation purposes. You use your GPS phones. We're completely relied on American GPS satellites, right? Slowly, some devices are getting relied upon European GLONASS, and now we have ISRO's NAVIC. So NAVIC compliant devices are also coming into picture, and there has been a mandate that every phone should have NAVIC compliant navigation system. Right. So we are building GPS positioning system. We are building satellites for imaging, and we are building satellites for communication. Right. So what I'm trying to say is, at GalaxEye, we are trying to solve one big problem or one big challenge, which is to miniaturize a Volvo bus sized satellite into a mini fridge, doing the same kind of imaging. And it is not just one discipline's challenge, it is not just mechanical engineering challenge to just compactize. It is also a semiconductor industry challenge. It is also an electronics discipline challenge. It is also a computer science challenge. It is everything put together, right? So interdisciplinary actions and mindset is super important. When you take a deep tech journey, if you do that, if you join a consulting firm or a software industry, I'm not sure whether you will have that fun of life. But if you are taking a deep tech journey, you will have to have that interdisciplinary mindset and a systems mindset to take up those challenges and build something which is very useful. So while building all of these things that we're building from India, there are three major challenges that we come across. Point number one, which I was also talking with the professor, was funding. Okay. Software, I just need a good laptop. That's it. I can do some 100 iterations on the same laptop, build a UI, build a backend engine, or something like that. And, like, even if it fails, it fails. It's okay. It's nothing, it's not burning an asset there. So funding is super critical for a deep tech startup, because there was one instance, there was an Ariane Space, which is a European launch vehicle that was going to space, and they were running a for loop program in Fortran language. And they ran one more loop. Instead of starting from I equal to 0, they started from I equal to 1. And because of one less iteration of that for loop, that launch vehicle blasted. Billions of dollars gone. So it's good that we can do iterations quickly, faster and better in case of software engineering, but it's not possible, unfortunately, in deep tech. You need to build something, burn, test, more destructive testings that happen. So one major challenge that comes across in any deep tech project is funding. What is the solution to that? How many of you have seen GitHub as a repository? GitHub, used GitHub? Good. Is there any GitHub for mechanical engineering? There is one, by the way. GrabCAD, right? So we need to build more reusable and modular ways to contributing to the community. And I hope one of you will probably do something like that. There's a company called Zetwork. I don't know how many of you listen to Zetwork. Zetwork helps you to manufacture faster, cut short the supply chain and stuff. So funding helps you to reduce your development cycles. Funding is a bigger challenge, and you need to modularize your process, your frameworks, to cut short your development cycles. Second big challenge is talent. The courses that we study or the projects that we do, and where India is currently in the deep tech journey, there is a gap. So we need to somehow converge that what is being done in the industry, we should try getting there and doing the same thing, so that there is a quick, or there's a good amount of access to the entire talent pool that we can get as startups, or industries can get as industries itself. For example, we are building a radar imager for our satellites. The talent is only available in ISRO. Nobody knows radar signal processing, right? So for us, there's a big journey that anyone comes in fresh from the institute or 2 works experience in Intel, Qualcomm, or anywhere. We have to take them through that training journey of understanding that radars are not just for detecting objects, it's also for imaging. So that is the second important challenge that deep tech projects or startups or company face. And third is, which is more an attributal level thing, which is, patience level of people, of team which is involved in the project, because because there is a significant gestation period for developing a particular technology. And if you don't stick to that, and if you hop from one point to another, that project is not going to finish anytime. And there's a lot of enormous amount of difficulties that comes to founders like us, right? So my suggestion to anyone who's probably going to pursue a deep tech project, or who's going to start a deep tech startup, or who's going to join a deep tech company or a startup, is you need to be aware that there is going to be limited funding, there is going to be limited know-how of the work that you're going to do, and then you need enormous patience to get into and step into that field. If you don't sign up for these three challenges, please go and join a software company. With that, I'll stop here. Happy to answer any questions you might have, and all the best for all of your careers. Thank you so much for inviting me.
Good evening, sir. It was wonderful listening to you. My name's Kritik and I'm doing third year mechanical in NIT Trichy. My question for you is related to your GalaxEye space. So it's about space technology. So you know that the world is being taken by a storm right now of artificial intelligence. AI is being integrated into everything and everything. So how exactly do you think AI will affect in space navigation? Like, do you think it is at one point it's going to replace human errors and humans? There is going to replace humans, and it will be make it more efficient in space technology, or would it be uh, derogatory? Like, do you think it will be detrimental to humans?
So to repeat your question, you asked like how AI is going to help space navigation,
Yes.
space objects navigation.
Yes.
All right. Yeah, sure.
Or would it help at all? Or would it help at all?
Yeah,
Okay, yeah.
it will for sure. So one of the biggest challenges in space is it is not the biggest yet, but it will become one of the biggest challenges in future is the debris. The lot of satellites are getting manufactured and sent to space, and some satellites actually collide and they become debris. So these objects are moving at 7,000 meters per second speeds and all, right? So now space navigation, when we deploy a certain satellite in the orbit, it always take a certain path. If you deploy a orbit in a polar orbit, it's going to orbit in the polar itself. If you put the satellite in an equatorial orbit, it is going to be in equatorial orbit unless it's deorbiting and stuff. Now AI here will help satellites to stay away from the debris. The AI will help it's the satellite to do some sort of PID in itself as a control mechanism, and to move here and there so that it can dodge the debris and can still come back to the same place again and again. Because every space object can't be monitored from via the telescopes that we have on Earth. That is why AI in space navigation will be super, super important. Although what is more important is how that AI model is being trained. What kind of sensors we are using? Are we using LiDAR? Are we using radar? Are we using camera? And to what nanometers of size of the particles we're able to detect? Plus, there is a big challenge. Like, we need to model it right. In space, it's not Cartesian coordinates. It's not XYZ. Right? In space, there's 6 degrees of freedom. So you need to identify the position very accurately to find and navigate here and there. And that AI can significantly help. So, yes, to answer your question, yes.
Hello, sir. I'm Aditya from final year. So now India has no discovered a lithium-ion reserve at Jammu and Kashmir. So, what visions or how do you think it will accelerate the process of introducing Hyperloop into for people's access, and how will it accelerate the project process?
See, to my experience, lithium or batteries will not be a sustainable solution for Hyperloop system. Um, if you put Hyperloop on DC power, or if you put batteries on the pod itself to move from one point to another, the pod mass will go up. And when it is going to go up, you have to redesign your structures, your chassis, and everything to sustain those forces and stuff. And then, so your pod mass will become heavier and heavier and everything. And because of that, you need more power to accelerate. So it's a bad solution to put batteries on the pod. Rather, we need something very similar to how railways work today, currently, right? So the power comes from the running electricity transmission lines, directly taking the power from there and giving it to the pods. So I don't think the discovery of lithium reserves will help Hyperloop in any ways, but I do think it will definitely help EVs segment entirely to move forward in a faster way.
Hello. Sir, this is Jalareddy Jagdish from Mechanical, NIT Trichy. Sir, my question is simple. What are the future promising applications we can get in AI exploration in space?
Right. One of them is asteroid mining. Right. So we need to identify what minerals or what elements is available on a space object, or a space object which is not man-made. And asteroid mining is a big thing which people are researching on. Second is the life of the satellite or life of any spacecraft. So if you can predict the life because of debris positions, because of the energy it is using, or because of solar panels getting deteriorated, or battery life is coming down. If you put these variables accurately in a model, AI model, it'll be very, very helpful in optimization of the life of a spacecraft. In exploration of space, I think it's a straightforward thing. If you apply, James Webb Telescope is a big example, of exploring what is going on. But AI starts from data, right? You need data. So what the efforts that is being made in space is to gather the right data. If you have the right data, then it's computer vision algorithms that you implement on, build a neural network, get to it. Yeah, so I think AI will be definitely helpful in exploring the universe, but even important than that is, what sensors will help us collect that kind of data.
Okay, another question. As a AI space researcher, do you believe in aliens? Or they exist?
I will reserve my comments on that.
No, it's not going to be controversial.
No, I don't know. Yeah, I've never studied on aliens and stuff. So I don't know. Honestly, I don't know.
Okay, thank you.
Good evening, sir. Thank you so much for the talk. My name is Jay. So you mentioned that you're attempting to miniaturize the size of satellites that are being sent into space. So can you share with us? You told about the different domains, like it's a domain challenge in semiconductor industry or a mechanical engineering industry or an electrical engineering, whatever it is. So can you share what exactly are the big challenges that you need to overcome in order to accomplish that? Specific ones, not just the domains that need to work on.
Challenge, I think the most important or the key challenge here is what works on ground or air. Will the same thing work in space or not? So ISRO's or NASA's satellite are so huge because they have like degree of uh, like the factor of safety that they have is above 4 or 5 or 6 for everything, right? And they have redundancies. So if their one system is not working, there's another system, backup system that is there in place to help that. So we need to understand what works here on ground. Will that same thing can work in space as well or not? For example, an electronics unit. I was also giving this example earlier in the day. If you use an Arduino or a Raspberry Pi here on Earth, you can use it in car or something. But if you go to space, it's going to have extreme temperature ranges. When you're facing the sun, it's going to heat up a lot. When you're not facing the sun and facing an eclipse, it's going to be in the cold state. So thermal cycling of the same electronics goes up and down. So these are the challenges. Essentially we need to understand the system that work on Earth. How does the same system will actually go and work in space? Majorly temperature is a big challenge. Second is communications. If your satellites are not able to communicate, how will you bring it back? How will you bring the communication back and still make it work like the way you want? Yeah.
Just a follow-up question on that. You mentioned that about verifying if things will work in space or not, and I presume that you use space simulation chambers for such purposes. Is that
You
accurate?
can.
You can. Okay.
You can. The only problem is space simulation chambers or all of those things are only available with big space agencies in the world. That's it, right?
Right. That was my question. So,
Yeah.
if there is such a scarcity for maybe, say, such essential infrastructure or facilities that we need, what advice or what would you recommend people who are looking to, say, establish deep space or deep technology space startup?
Mhm.
And what should we go and establish it abroad, or would you recommend doing it indigenously? So what is, like, is there a best of both worlds approach? What is your recommended
Yeah.
answer to
So
that
it's
question?
all about the cost versus time uh, game plan, basically. You need to understand if you do, there is a concept called um, screening of electronic devices. So the same electronic or FPGA or a board can can sustain all the temperature ranges, and the same model's second piece or second unit may not work for all temperature zones. So what you do is you build small setups, small temperature or thermovac chambers, which is not relatively larger to fit the entire satellite into that, but test components, right? So I think it's an optimization problem of the development process of how big space agencies do. Because if space agency fails, this is a big problem because it's on nation, right? It's on the image of our country. But if a startup fails, it's okay. People will laugh and say, okay, no problem. Tomorrow, come back again. So it's okay to fail for us. It's not okay to fail for them. So they will do a lot of redundancies. They will do some 100,000 checks before launching a satellite or a launch vehicle. For us, we can still do something here and there, cut down the costs, be frugal as we can. And if you have a proven space system with the level of frugality that we can bring on the table, then you've done the best. For example, synthetic aperture radar satellite in the US or in India was built for $40 million initially. A company in Finland called ICEYE brought the cost down to $8 million, 5 times. They implemented those optimization things in place to get that. I
Thank you
hope
so
that
much,
answers
sir.
your question.
Yeah. Yes. Thank you so much.
Hello, this is Savar. My question is on a very general sense. Even though privatization has increased in the space field and like related fields, but still a very government dominant industry. So, as a private player, how has the government helped you? And at the same time, since there are security issues, what kind of hurdles has the government created for you in such a field?
Um, yeah, I think government is pretty supportive of everything today. They have formed an entity called InSpace. Uh, so there is a department of ISRO called InSpace that interfaces with private startups to help them in a lot of things. Access their test facilities inside ISRO, access spectrum allocation in orbit, do the space object registration with the UN and whatnot. So I guess it's very supporting environment, not a problem. Um, Second part of the question was
Hurdles.
hurdles.
Yes.
See, I think every startup has to go through a lot of hurdles in place, and I don't think so in terms of policy or security there is a lot of hurdle in that way, because there are defined protocols that you need to follow, and those are pretty well defined. So when you're starting your design or you're manufacturing anything, you start with those constraints or the boundary conditions, right? So you don't actually go beyond it. I don't think so. That is a big challenge altogether. Uh, Big challenges are on majorly that I talked, before: funding, talent, and perseverance. So those are the main three things that anyone faces in deep tech.
Thank you.
Good evening, sir. This is Vishwa from final year mechanical. I had a doubt regarding the fact that you told that any deep tech company or project faces is the gap between the education that we are given today and what the industry is working on. So, for you, before starting GalaxEye, what acted for you as the bridge to identify the active problems and gather the confidence and the knowledge to pursue them and solve them?
So see, I think in my case, because I spent some time with the industry, so when I was working with TCS Research and Innovation, I worked on a problem uh, in the US where there was forest fires in California, and uh, one of my manager came and said, "Hey, there is a client who and there's a client who has a transmission line, and because of them the forest fires got erupted and it was spreading, right? So we were all tasked to use satellite imagery to analyze forest fire situation there, right? And when we were trying to do that, it was not possible from the current satellite imageries which were there, right? And when it came to my mind that, hey, is it possible for me to build a satellite that can give me the best of the data to manage or to understand that forest fire, I can actually be a better guy in the industry to serve TCS or those people or to control those fire situations, right? I will not go into what was the detailed thing, but I will tell you that that kind of bridged my thinking, or I got a real problem to solve because I was working, right? But I think even Hyperloop was one of our good problems that that could have given me another bridge to start on. For example, linear induction motors. Today we have belt and conveyor model everywhere we use, right? Which is too difficult to maintain, which is too difficult. Like bearings and everything has to be replaced, then belts have to be replaced, and all of those things. It's better if we can build a linear induction motor platform and just move things linearly here and there. It's a simple one-dimensional model to work on that. So I think if you keep your ear and eyes open and look for problem statements given by industries or agencies or governments, I think those are the problems that you should try to tackle. For example, there are challenges that you will always find on some of the other website or some of the other guys starting a competition. Like Hyperloop was one. uh, EVs when started up, E formula was one. So look for those kind of challenges. Like sounding rocket is one, CanSat is another. So look for those competitions. Try to participate. You know, try to do a project into that. Learn from that experience, and then if you really like, either join a company which is doing a similar work, or if you think there is no company doing that, and if you have the capability, start a company yourself. Yeah.
Thank you, sir. So, one small follow up on that. Uh, when you identified a potential problem, when you have the basic knowledge in that field to, uh, you know, push your vision into that thing, how do you go about gathering the knowledge and the infrastructure to pursue it at an industrial scale or as a project of yours itself? Like, it's a very, you might find this vague, but
No,
to
I think
develop
it's
that.
I think it's a valid question, although it answers to that question is different for different people. For example, in my case, I had a team which worked on Hyperloop, so I went back to them. I gathered the team and we started working on that. And I trusted them like anything. So those are the best people on earth for me that time to rely on, right? But I think there's enough curiosity in engineering students today, and people are trying to solve more ambitious problems. So the answer to your question, vaguely answering your question, go and attend a lot of networking and conferences, events. Try to find like-minded people, and then start small. Don't try to start big on day one. Start small. Put a very small milestone on your chart. Try to achieve with those people, and if you really think that that's happening, then double down, or else take a step back and restart. So there's no answer to that question, right? Because when even Elon Musk started SpaceX, he went to a conference in Los Angeles, some science conference, and he used to spend a lot of time there. Then he found Jim Cantrell, who he took to Russia to understand how Russia was building Soyuz and stuff, right? So it's, if you have that hunger, you will find your own ways, and you have to start from the point and the nodal points that you already have, instead of looking in haystack. Yeah.
Thanks a lot, sir. Thanks a lot.
Good evening, sir. I'm Sindhuja. Very inspiring talk. I have a question like, are there any ethical issues in using AI, like or in collecting the data? I think you're collecting the data across the globe and then using it to solve any in on any applications. So is there any issue like some certain areas may be prohibited or people might be afraid to give their data, like what if we may use for any other purpose or some.
Right. So very valid question. I think it's a two-part question. I'll answer the second one first. So, see, when you build a satellite and you register your satellite with some government agency, you can't have a resolution which is more than 50 centimeters, 1 pixel, right? So basically, you can't track people. It's you can only see what's there on the ground as an infrastructure. You can't see people through satellites. It's too costlier to build a satellite which is 1 centimeter resolution, like our phone's camera, right? B, it's not possible because government will never allow you. So 50 centimeters. So security of people is already there. Yes, and the second is the satellite imageries are always regulated. So our satellites can never image few negative areas. For example, border. Even if we image borders, we need to give that to the government itself. We can't give it to anyone else. So selling that satellite imagery is not possible if it is not regulated. So that is the answer to your second question. First part question I'll probably answer in this way, that how many have you tried that machine learning algorithm to identify a cat and a dog with the neural network? So there are some n number of images having cats and dogs. Good. Okay. So very few. But if you start learning neural networks, this is the first thing that probably is a hello world problem, that you have to identify a cat and a dog in an image. That is the first machine learning or a deep learning problem that you'll solve, right? But then how does it happen that it became a hello world problem? Because Google one day collected some 1 million images of cats and another million images of dogs, and they curated a folder and kept it there. And in every image there was only one cat, and another image there was only one dog. Either dog was sitting or jumping or standing, it doesn't matter, but there was a dog, at least one dog in one image. Similar things are not so okay. So the cat images and the dog images helped, or a lot of Google images helped us to build machine learning and deep learning models of today. If you see Google building an autonomous car, it's only possible because there was a lot of data that was generated on Google images. We all contributed to those images. And there was a model that was trained on top of those images to detect a car or a truck or a bike or human or whatever it is. Similar data set is not available from space. Because from space we see like this. And cats or dogs we are seeing from this perspective. From space we have to see from the top. So it's very difficult to build machine learning models or AI on top of satellite imagery today because there's a dearth of data. So I think there's a huge amount of scope. The challenge is we need to get more and more data from space. And for that, I think we need to build more and more satellites. And for that, I think we need to build more and more companies and more talent to build those satellites. Perfect. All right, guys. Thank you so much for your wonderful presence.
Thank you, sir, for addressing the questions. Thank you for your very informative and inquisitive lecture. Your words mark a deep ambition and vision in the minds of the students to march forth for their future goals. Thank you, sir. This marks the conclusion of guest lecture series. With great pleasure, I would now like to begin this valediction ceremony. We are humbled to have you all present here to see the making of the grand success of Synergy 23 with the theme Symphonic reviving back the offline edition after 2 years. In this glorious evening, we all are gathered here to mark a sublime wind-up to the synergic rapport of the triumphant symposium. With that note, we welcome you all to the valediction ceremony of Synergy 23, the annual National Technical Symposium of the Mechanical Engineering Department, NIT Trichy. We would like to thank our sponsors for your constant support and contribution for this edition. We express thanks to our associate title sponsor, Indian Oil, ride partner, Benelli Kiwe, fashion partner, Pothys, lifestyle partner, Kalyani Covering, official tech partner, Robonetics, regional cinema partner, LA Cinemas, style partner, Green Trends, coupon partners, The Launch, Singapore Plaza, and Tip and Top, social media partners, I Love Trichy and Trichy 360. Synergy certainly wasn't the only thing that happened this year. We have had a lot of events showcasing prominent personalities from different industries addressing on our interests. We would now like to invite Abhicharan, the technical head of Synergy 23, to present the report of the Mechanical Engineering Association 23.
Right. So, hello everyone. I'm Abhicharan and I'm the technical coordinator for Synergy 23. And I'd like to thank our chief guest today, Mr. Suyash Singh, for taking time and accepting to be the guest lecturer for today's event. So, good evening to everyone. And our esteemed chief guest, our HOD, my fellow classmates, and all guests gathered here. Believe yourself and you're halfway there. This was a motto that our seniors gave for us. This was a benchmark that they had set for us. And as the Mechanical Engineering Association for this term, we certainly had to outshine them in every possible way. And we tried our best for it. The team of MEA XCOM was formed between May and July 2022. This was a wonderful team. And with this team, we had multiple initiatives and were working on more for this academic year. And we certainly are curious to execute them. Initially, we began with the Google Calendar initiative, which helped students to organize and collaborate with professors, teaching assistants, and the class reps to fix deadlines and know what is coming up next. We then moved on with Intern Talk, one of our flagship events to help sophomores who had doubts about internships, and any research internships or any company internships. And we had seniors who had done their internships come and talk about their experience and many other such related initiatives. The next flagship event is SYNC, short for Synergy Networking Consortium. The career opportunities after fourth year are in plenitude. To help students to decide on a career path, to gain knowledge on which path they would like to choose, this initiative helped us. With the help of the networking and speakers forum of Synergy 23, headed by Aditya Modi and Shish Sharma, whom we are thankful for, we were able to bring in distinguished alumni who are currently working in various fields such as ISRO, etc. And we were able to ask them questions and get our doubts cleared, our students' doubts cleared, so that the students know what career path they are interested in. The next initiative is Mesh with Mech. The technical scenario in this world is constantly changing, and it is imperative that we do so. Mesh with Mech is a series wherein we give out snippets of information on the latest developments in mechanical engineering, and these will be regularly posted on our Instagram handle after Synergy. The next initiative in the works is Mentor 2.0, which guides students interested in particular fields to get awareness of the opportunities in that same field. This mainly is aimed by encouraging discussion between seniors and juniors and helps in transfer of knowledge the same. The next initiative that is to be carried out is Destroy the Dilemma. A lot of students who are excited to pursue the higher education often find it difficult to gather much information about it. Here, we bring in our seniors, our people who have got their admits or who are currently studying abroad to share their experience with our juniors and guide them in their process. Next, we have an interesting initiative, the MEC magazine. It's going to be an annual magazine or a yearbook which will be released at the end of the academic year and will contain all the activities conducted by our department, all the laurels that our department won, and all the works that its students, professors, and staff have carried out in the year. The final year students who will be graduating will be receiving it as a hard copy, and it will be a small memento from our side to the students. I'd like to thank all the Mechanical Engineering Association members, the fourth year EXCOM members, Chairperson Vigneshwaran, the oral coordinator Nainika, the treasurer Abhirat, and the quality assurance team head Jana Tini. I'd also like to use this opportunity to thank the third year students, the Vice President Jain Nayak, the General Secretaries Vignesh, Ujjwal Tiwari, and Vishal. And finally, the second years, Naman Goel and Varsha, the Joint Secretaries, Kushi Chowdhury, Radna Manikanta Sai Neeraj, and Amitesh Karthikeyan, the Additional Joint Secretaries. I would also like to thank the technical team for their support throughout the year. With this, I would like to bring an end to my report on the Mechanical Engineering Association, and I would like to use this opportunity to thank everyone here, including the Chief Guest, HOD, students, and staff who have joined us today evening. Thank you all.
Thank you, Abhicharan. The last 3 days seemed to go in a flash with a plethora of events, workshops, guest lectures, and other informal events. It all felt like a remarkable reminiscence. We would like to invite Abhirat Raju, the treasurer of Synergy 23, to present the report of Synergy 23.
Hello everyone, good evening. I am Abhirath Raju, the treasurer of Synergy 23, and I will present to you the report of this edition of Synergy. No pain, no gain is the most famous quote we have ever heard of every time it pays off with Synergy, with what Synergy does. Synergy 23 has only been onward and upwards for us this year. It all began in September when we conducted inductions to juniors for each team. Since then, each team has put much effort into Synergy. This is what we see as a fruit of the hard work we have put in. As the quote says, no pain, no gain. The struggle that has been put in for the past 6 months is incredible. Here's a report of what Synergy 23 achieved. On day 1, we had workshops on automotive protokindling, 3D printing, and an event called CAD modeling with a participation count of 70 people. They were a grand success as we had more than 100 participants in each workshop. And on the same day, we had a guest lecture from Dr. G. Satish Reddy, an internationally renowned defense scientist. The guest lecture was so insightful that every participant gained immense knowledge and life experiences, approaching a footfall of around 200 people. On day 2, we had air modeling and industrial robotics workshops with around 100 registrations, including events like quiz, crafted, and paper presentation, which enlightened us on the processing of various fields and gave the participants a hands-on experience. Later that evening, we had a guest lecture with a footfall of around 120 people by Mr. Ajit Patil, the founder and CEO of Rivet Motors, Fast Broadband, Out of Box Cloud. He spoke about his passion for mechanical engineering and how he used his experience in the electrical field to associate with mechanical engineering. He gave valuable guidance on managing startups, giving us a lot of inevitable knowledge. On day 3, we had workshops on SolidWorks and electrical vehicle design with nearly 80 registrations and events namely contraption, lathe off, and arm painting with a combined participation count of 75 people. Following that, we had a guest lecture by Mr. Suyash Singh, co-founder and CEO of GalaxEye Space, which was very insightful and informative with a footfall of over 150 people. The marketing team had phenomenal converts this year, securing a whopping 13 sponsors this year, making it possible to conduct Synergy in a grand manner. I hereby conclude the report of Synergy 23. As the term Synergy suggests, it's all about connecting and coming together as one. This edition of Synergy has proven how everyone has joined and worked together with solidarity and unity. We had a magnanimous footfall count of 1,103, putting together online and on-spot registrations. With this, I declare Synergy 23 a prodigious success and thank our HOD Dr. Panniselvam sir and the faculty advisors Dr. Rajsekharan and Dr. Raghuram for their constant and everlasting support. Thank you.
Thank you, Abhirat. We now call upon Nainika Gulla, the overall coordinator of Synergy 23, to present the vote of thanks.
Good evening, everyone. It takes immense pleasure to welcome you all to this valediction ceremony. I'm really gratified for giving me this chance to deliver the vote of thanks. I, on behalf of Synergy 23, am obliged to the audience for their momentous presence in this valediction ceremony. I especially want to thank our respected chief guest, Mr. Suyash Singh, sir. Thank you, sir, for accepting our invitation and for being with us today. Thank you, sir. Uh, and for giving his precious time with us. You surely have added to the charm of this inauguration with your vital presence, sir. Your words have truly inspired us, and we will surely follow your guidelines, sir. I'm sure that your deep and intellectual way of imparting knowledge has engraved inspiration into the hearts of the students. I further pass my gratitude towards our esteemed director, Dr. G. Agila ma'am, for always supporting us and motivating us. Ma'am, we thank you a lot for giving us a chance to conduct the wonderful valediction ceremony. The mechanical engineering department and Synergy have always prevailed because of the constant guidance and support from our respected head of the department, Dr. K. Panniselvam, sir. Thank you, sir. I would also like to thank our faculty advisors of Synergy 23, Dr. G. Rajshekharan and Dr. Raghuram Desu, for assisting us with their enduring support and guidance. I would also like to thank our chairperson, Mr. Vigneshwaran K, on behalf of Synergy 23 for leading this symposium. Finally, a symposium of this eminence wouldn't have happened without the support of each and every student. So I'd like to mention the core who have worked with me so far to make this synergy a grand success. So I would like to mention each and every team name by name, starting off with the ambience team headed by Kavya Vijay Kumar, and the content team headed by Tejashwar Karthikeyan and Sayani Haldar, the design team headed by Jay Kumar, the events team headed by Nachiket Kulkarni and Rakshit AVR, the marketing team headed by Mohit Sharmana and Rafat Banu, the guest lectures team headed by Aditya Modi and Sri Sharma, the organizing committee headed by Shaktivel, the publicity team headed by Danish Kumar B and Aditi B, the public relations and hospitality team headed by Hariharan and Aditya Ram, the quality assurance team headed by Janardani R, the technical team headed by Abhicharan P, the WebOps team headed by Nishi Agarwal, and, and the workshops team headed by Yuvan Nidishwaran and Kavin Narayan. With all the accomplishments of Synergy 23 being attained, it is because of the solid efforts and the zeal of the people who put their heart and soul into this never-ending diligence behind these feats. I express my heartfelt gratitude to all the people who thrive for the grand success and advancement of Synergy 23. Again, thank you all for your energetic participation, and I'm sure that the success of this edition shall motivate the next batch to aim for higher and excellence. I hope this synergy will bring many more innovations and pave the path to hone the skills of young minds. Once again, thank you all for being present during this valediction ceremony. And this is Nanika Gulla signing off as overall coordinator, Synergy 23. Thank you.
Thank you, Nainika. With that, we have come to the conclusion of the valediction ceremony. The 3 days are just a technical symposium, but the aura of the zeal, effort, and rhapsody that we have for Synergy 23, which makes it a prominent marvel now and forever. Sustaining the legacy of motives and outreach, Synergy 23 is indeed a colossal victory. We thank you all for being here to witness this great offline edition of Synergy 23 and hope to see you all next year with a bang. I now request people who are interested to interact with Mr. Suyash Singh, sir, can move to A2 Hall for a student interactive session. Once again, thank you.